Good morning. Here is your review sheet for test 3-7, which is going to be tomorrow. Just make sure you have your calculator out and ready to go before you do this review sheet. So question 1, a wall is supported by a brace 5 feet long. At the end of the brace is placed 3 feet from the base of the wall. So here's the wall. And then it's 3 feet from the wall. How many feet up the wall does the brace reach? So I'm looking to find this value, and I know that the brace is 5 feet long. So I'm going to draw a diagram, which we already did for you. You just have to fill it in, and we're going to show our work. So we see that this is a right triangle, because the building makes a right angle with the ground. And so I'm going to use the Pythagorean theorem, which is a squared plus b squared equals c squared. So when I set that up, the longest side is always c, so that's always the side that's across from my right angle, which is 5. And then my two legs are x and 3. And then I'm just going to solve for x. So I get x equals 4 feet. So that's my answer for number 1. Number 2, I have triangle ABC, and then they filled in my angles for me. So I want to solve for x. This is going to be your exterior angle theorem. So that means that the two inside angles add together to equal the outside angle. So I'm going to solve for x, get all my x's on one side. So I get 50 equals 5x, divide by 5, x equals 10. Number 3, the degree measures of triangle ABC are represented by, so I'm going to draw triangle ABC. Angle A is 3x. Angle B is 2x plus 10. And angle C is 4x minus 10. Which side of the triangle is the longest? So I know all of those have to add together to 180. So I'm going to solve for x. So that was my first step, and now I need to find all of my angles. So angle A is going to be 3x. Angle B is going to be 2x plus 10. And angle C is 4x minus 10. So I want the longest side, so the longest side is going to be across from the largest angle. My largest angle is angle C. So across from angle C is side AB. And that's my answer. Number 4, solve for x. I'm going to distribute my -6. Combine my like terms. Bring all my x's to one side. x equals -9. Number 5, tell if each of these sets of numbers could be the measures of the sides of a right triangle. So I'm going to plug these into the Pythagorean theorem. 3 squared plus 4 squared equals 5 squared. So that would be 9 plus 16 equals 25. So that works. So that's going to be yes. Then I'm going to do the same thing for the next two. 12 squared plus 35 squared equals 37 squared. I'm going to plug it into my calculator. So all of them end up being yes except for D. And for that we plugged into a squared plus b squared equals c squared. And remember, your c is always your longest side. Number 6, measures of the angles of a triangle are x, 2x minus 15, and 2x plus 20. Solve for all angles and state what type of triangle it is. So first I'm going to solve for x. Because all of those have to add together to 180. I'm going to combine my like terms for 5x plus 5 equals 180. So I get 5x equals 175. And then I'm doing 175 divided by 5. And I get 35. So now I have to solve for all my angles. So my x angle is going to be 35. 2x minus 15. It's going to be 55. And then 2x plus 20 is going to be 90. So my triangle is going to be right because I have a 90-degree angle. Remember, an isosceles triangle has two equal angles. A right triangle has a 90-degree angle. An acute triangle has all angles less than 90. An equiangular has all equal angles. In triangle ABC, AB equals 8, BC equals 9, and AC equals 10. List the angles of the triangle in order from smallest to largest. Okay, so AB is 8, BC is 9, and AC is 10. So smallest is going to be across from the smallest side. So that's going to be angle C. And then my next smallest is going to be across from the 9. That's going to be angle A. And then my largest is going to be across from the 10. So that's going to be angle B. In isosceles triangle DEF, DE is congruent to EF. Which two angles of this triangle will be equal? So remember, your base angles are always going to be equal, the ones that are across from your equal sides. So that's going to be angle D and angle F. the diagram of triangle ABC, AB is congruent to AC. The measure of angle B is 30. What is the measure of angle A? Okay, so this is an isosceles. Triangle, so these two sides are equal, so that means that angle C and angle B have to be equal, and I'm looking for angle A. So I'm going to do 180 minus 30 minus 30 to find my missing angle, which gives me 120. Mary is cutting a triangular piece of tile. If the triangle is scalene, what set of numbers could represent the sides? So scalene means all three sides are unequal. That's on your post-it from a few weeks ago. So I'm going to get rid of choice B because that has two equal sides. And then I'm going to try A and C for the triangular inequality. So I'm going to add up the two smaller numbers, and I get 6. Remember, when you add them together, they have to be longer than the third side. 6 is not longer than 7, so it can't be choice A. And then I'm going to do the same thing for choice C. 3 and 4 is 7, and 7 is bigger than 5. So that works. So it has to be C. Two complementary angles are represented by 3x minus 10 and x plus 20. Solve for x. Complementary means add to 90. So I'm going to add these two. And I'm going to solve for x. Combine my like terms. Negative 10, positive 20 gives me positive 10. And then I'm going to move my 10 to the other side. And I get x equals 20. For number 14, I'm going to list all my vertical angles. We've done this before. It's angles that are across from each other, like that. Alternate interior. Remember, they have to be on the inside of the parallel lines. So here's the inside, and they have to be on the opposite side of the transversal. So it's going to be 4 and 5, and 3 and 6. Alternate exterior angles. Now these have to be on the outside of the parallel lines. So it's going to be 1 and 8, and 2 and 7. And then corresponding angles, remember they're in the same spot. So 1 and 5. They're both in the top left corner. And then I have 2 and 6, both in the top right corner. And then I have 4 and 8, bottom right corner. Then I have 3 and 7 in the bottom left corner. For number 15, these make a Z. These are alternate interior angles, which are congruent. So I'm setting these equal to each other. And I'm solving for x. So x equals 17. And then the last one, number 16, I have triangle ACD, and point B is on AC such that triangle ABD is equilateral. So this is equilateral, that means all my sides are the same. And all my angles are the same. So when my angles are the same, they're all going to be 60. And you can just memorize that, or you can do 180 divided by 3, because they all have to be the same. And there's 3 angles. They're telling me that DB is congruent to BC, so that means this is also congruent. Find angle DBC. So I'm looking for this angle up here. A couple different ways that I could do this. First thing I'm going to do is I'm going to find out what this angle is here. Angle DBC. And the way I'm going to do that is I know these angles add up to 180. So I'm going to do 180 minus 60. And I get 120. So right here, I have 120. I also know that this is an isosceles triangle right here because 2 of my sides are equal. So that means that these 2 base angles are going to be the same. So inside my triangle, I have 180 degrees. I'm going to subtract that 120 from my vertex angle, which gives me 60 degrees left over between those 2 angles. So I'm going to divide that by 2, and each of these have to be 30 degrees. So that means angle DBC, angle BDC is 30 degrees.